Okay, everybody. Well, let's get started. We have some excellent content coming up. Thanks for joining today. We're excited about this webinar. My name is Keith Wright. I'm the CEO of the Millennium Water Alliance. And just briefly, MWA is a global alliance of leading humanitarian, research, and business organizations working together so that every community and their ecosystem are water secure. And to reach this goal, MWA delivers global water security and resilience results by mobilizing a community of expert members, some of which we'll hear from today, driving collective action and thought leadership, and influencing strategic funding. So today's session is an example of that convening for learning and collective impact on critical issues and opportunities for our sector. And we're excited to be a convener of today's session on AI and water security, along with MWA members, the Water Project and World Resources Institute and Friends at Aquia and Baobab Tech and others. So today's session is about identifying the problems that AI can help us all solve in the water security and resilience space. And the three case studies in this webinar represent different stages of AI adoption, from a fully deployed operational tool to an initiative in the design and planning phase. So together, these case studies illustrate what it looks like to conceive, build, and launch AI-enabled solutions, highlighting the considerations and learning that arise at each stage. So we have something for each of you. And we hope that by presenting work at various stages, you'll get a sense of the challenges and opportunities, and that it will resonate with all of you, regardless of your individual and organizational experiences with AI. So welcome, we're delighted you're here. And Audrey, I will hand back to you.
Wonderful. Thank you so much for those opening remarks, Keith. Welcome again, everyone, to this event. My name is Audrey Caprio, and I am the Global Knowledge Management and Learning Officer with the Millennium Water Alliance, and I will be your event MC today. Before we get started, I wanted to cover some housekeeping rules. First, this session will be recorded and shared following the event. Additionally, live translation captions are available. If you click on the three dots at the top of your Teams banner that says More, go to Language and Speech, and Show Live Captions, you can enable that feature. The default setting is set to Spanish, but you can also change this to French, Japanese, or Portuguese. And you may click on, to do that, you may click on the gear icon in the upper right corner of the live captions box to change that setting. We welcome all opinions during this session, but we remind everyone to please be kind and respectful during discussions. Additionally, we ask that everyone be present and ask questions during this event. To do this, you can utilize the Q&A feature, again, found at the top of your Teams banner. And we ask that you utilize that for questions, but feel free to share your experiences, challenges, and lessons learned around using AI for your work in the chat at any time. You may answer questions or ask questions at any time during the event, but we will save them for the audience Q&A in the second half. Here you'll see a quick agenda for the event. After we finish setting the stage, we will hear from our keynote speaker, and we will follow that by three excellent case studies, again, showing how organizations are designing, testing, and applying AI-enabled solutions in the water security and resilience sector. Then we'll pivot to a panel and audience Q&A where we'll try to answer all your questions. And lastly, we'll wrap up with some final messages, key resources before closing the webinar. Before we get started, I want to take a second to stop and ask a question to the audience. We would like to know, what is your biggest barrier to using artificial intelligence? To answer this question, you can scan the QR code on screen. I'll take you to the Mentimeter. You can also go to this link that I'll put in the chat in a second, or you can go to menti.com and type in this access code. But we want to hear from you on, again, what is your biggest barrier to using artificial intelligence? So take 30 seconds or so, think about it, answer the question, and I'll project the results. All right, we're already seeing some results come in. Looks like there's a big gap on lack of knowledge and existing tools on what's out there, lack of trust or concern about ethics. That's definitely two things that we'll be talking about today. Also seeing a lot of people respond budget or resources. Give it another 30 seconds or so. Thank you all so much for responding. Feel free to continue to respond throughout the event. And this is very helpful for us to know too what struggles everyone's facing around using AI or getting started. And we hope that this webinar will help to solve some of those pain points. All right. So now I'd like to present our opening speaker, Dr. Samuel Shagun. Dr. Shagun is a co-founder of the QLOX Labs, a senior program manager on the Global Center on AI Governance, and a senior researcher at the African Hub on AI Safety, Peace, and Security at the University of Cape Town. As a reminder, please feel free to ask Dr. Shagun and any other presenter questions in the Q&A box, and we'll try to answer them during the audience Q&A portion. Dr. Shagun, over to you.
Thank you very much, Audrey. Hi, everyone. And I hope we are off to a very good start. I see that from the Mentimeter, we've got a couple of barriers around ethics and others around accessibility as well. And so the ethics bit about trust, we'll try to talk briefly about that in about 10-minute window that I have. What I'll be doing today is basically setting the foundation that would help us to do the case studies. And so we'll talk briefly about like what really AI stands for, what it is, what it's not, and some other framings that we should keep in mind as we go into looking at the case studies. Next slide, please. Great. So very often when we speak about AI, there's this conflation of certain concepts that is discussed in computer science and often makes the conversation around AI very confusing for many people. Simply put, when we speak about AI, we are talking about a branch of computer science that focuses on enabling machines to simulate human intelligence, such as learning, reasoning, problem solving, and perception. And this can come up in different forms. So from the very basic ChatGPT that we use, which is not really basic, but that's the one many people had access to that gave them the idea of what artificial intelligence is about. It's a foundational concept in computer science. When we speak about how do we simulate human intelligence, there's several ways that we can do that. One of those ways is often what we refer to as machine learning. So now machine learning is a systems where we train an algorithm to learn patterns from data, and then it's able to make predictions or decision making. And this is done without you explicitly training or coding the system to do that, right? And this is predominantly where we see what is called applied AI, where we take AI and use it to solve certain problems, maybe in bookkeeping, maybe in water security and water resources, or any aspects that we see that's often referred to as applied AI. And machine learning is often the technique that is used to do that. Another aspect of AI that we see very often is predictive analytics. Well, this is a subset of machine learning where we do things like forecasting using historical data. So we could, for the water sector, for instance, we could do things like pump failure prediction, flood risk modeling, and demand forecasting. It's also used for businesses where they're able to do a forecasting of the customer base, trying to figure out when they get the most sales, what time of the day or what time of the month or what time of the year they get the most sales. Usually that aspect is called predictive analytics. Then coming down to what we all are familiar with in the last few years, which is generative artificial intelligence or generative AI. Here we have models like, ChatGPT, Claude, Gemini, DeepSeek, and Quine models and the rest. The idea behind generative AI is how we could train an artificial intelligence model to be able to generate new texts, new code, new images, new sound, or whatever. And oftentimes it's very, very useful for knowledge work. So oftentimes what would require repetitive tasks, you could use it like maybe writing an email, maybe writing a memo within the organization. You could use generative AI to be able to do that. Now, key concepts that we need to keep in mind when we speak about artificial intelligence, one includes training data. Now, AI systems they would not be functional without having a set of data. So data set is what we use to train an AI system to simulate intelligence, right? So one of the things that we talk about very often when we speak about the ethics of AI or we speak about AI safety is to say there's a need for us to have both quality and diverse data because that would impact the quality of the outputs the AI systems would produce. The other thing we need to talk about is what models are. So models are algorithms that are trained, and the model is not really a thinking thing. It just identifies statistical patterns in data. And when new data is fed to it, it's able to identify similar patterns and it's able to give you like a prediction or provide you with an answer. One of the things that's not included here in the slide that is important to think about is algorithms. So you often hear people talk about algorithms. Algorithms are basically instructions or step-by-step guide to carry out the task. So cooking, for instance, baking comes with an algorithm. So when you have a recipe, that is literally an algorithm to be able to make a lemon pound cake or a banana loaf bread. Let's talk about inferences. So you might have been hearing the discussions going around, inferences and AI and inference machines or inference systems or inference models. Inferences here refer to when a trained model is applied into like new data set that it generates as prediction or output. So basically, the way we use inference as humans would say, I infer that something happened is almost a similar, it's almost used in a similar context as inference when we refer to AI. Then we also have the concept of human in the loop, which is one of the principles many organizations try to put in the workflow of their AI systems. What this simply means is designing AI systems in a way that puts human in as part of the decision-making process, right? So you design it with the idea that you want humans to review this. This is often used in very highly sensitive areas when you apply AI to. For instance, in water resources, you might have an AI system determine, for instance, how much chlorine should go into, say, a water that is put out to people. And you would want to put a human in the loop to be able to verify that the count or the number is correct. Another thing we talk about when we speak about ethics is often what is referred as bias. Bias can come in different forms. It could be bias in the design of the algorithm. There could be bias in the data set, which is oftentimes very prevalent. Usually, these are systemic errors or systematic errors that are baked into models and the outputs that the models produce. So that is often referred to as algorithmic biases. So biases that are probably not really seen or are there in the data set because humans put the data set together and the data set is often a reflection of what goes on in society. So if there's an error in the data set, it's also going to impact the quality of the output of the model. Next slide, please. So what is AI and what AI is not is a very important conversation to have. One of the misconceptions very often that we see is people think about AI as chatbots, and this is largely because the first interaction many people had with just visualizing the capability of AI as a technology is with maybe ChatGPT or maybe Gemini or one of the generative AI models, and because that's often the first, interaction people have with that sense of AI. There's this idea that AI is about chatbots. AI goes way beyond chatbot. For most AI used in the water sector, it's often machine learning based, so it's still very calculative, it's very predictive. So predictive models, you have something called anomaly detection, where we're able to maybe detect fault rate for certain maybe pumps, fault rates for certain generation machine, maybe distribution centers and the machines that are used in those centers. You also have like satellite imaging analysis that is often used to like map out maybe flood patterns or water reduction in a reservoir or something. And this is not really about chatbots, right? We also have the misconception where we assume that AI makes decisions automatically. Whereas that might be true in certain contexts, in other contexts, particularly the one we're discussing today around around the water sector, a well-designed AI system often has a human in the loop, where humans retain the decision making to be able to review the AI decision. So decisions are not automatically made. There's always a human who provides some level of oversight here, and the human often has the knowledge to do that. Then we have the idea that AI is value neutral and AI is without error or AI is objective. And this often happens where it creates what is often referred to as the automation bias. This is the tendency to just assume that whatever answer that you put on ChatGPT or you put on Gemini or you put on Claude, whatever answer it provides to you, you just assume that it is correct, even sometimes when it's widely wrong. And the times when it's wrong, it's often referred to as hallucination, where it makes a guess as to what the response is and says in a very convincing way. Now, AI systems are often not without errors. So it's important to know that because they are trained on data and data also is not without context, it's possible for the predictions or the answers that AI systems provide to be wrong, right? And an example would be if there's a knowledge gap in the training data set for an AI model, it's possible that the AI model will provide a wrong answer. So quick one, much of the data sets that was used to train many of the models we have did not really have proper representation in many parts of the world, what is often referred to as the global majority. So there's about a 70% of the data sets used to train AI was trained on American and European data and in English language predominantly, and a few select European languages, which means if you're having an interaction with one of those models in a different language, there's a tendency that it will provide or they'll produce very wrong responses. Okay. Another thing to talk about is just like a quick look at how AI has been used in the water security sector for a while now. Also, the tendency is that people assume that AI is just something that started in the early 2020s with ChatGPT or something, but it's been used for a very long time. For instance, in the 1990s, we had flood forecasting models, where these are machine learning based hydrological models that are used to predict flood in river basins across Asia, and we saw that in Europe as well. In the 2000s, we had a lot of work around remote sensing and classification, where satellite imageries and supervised machine learning were used to map out water bodies and detect land covers, land cover change, and monitor groundwater and the rest. Then we also have predictive maintenance in the 2010, and lots of works that have been going into predictive maintenance, where we have machine learning models that are applied to sensor data for like pipe failure to be able to do anomaly detection. So we can tell if the water is pumping if there's less water being pumped or more water being pumped. And in the 2020s, that's when we got introduced to generative AI, or what we now call foundation models. Here we have tools that are built on what's called natural language interfaces or natural language processing, where we can actually chat with an AI in English language and it's able to provide us with a response. So some examples of these would be like Aqueduct AI and Project W Search that have been able to help people to carry some work in the water resources sector. What we are looking at going forward is some sort of integration of decision-making system, where we combine both real-time sensing data, predictive models, and human in the loop to create governance for water risk management and the rest. And there's a lot of work going on and experiments going on in this area as well. Next slide, please. Okay, so 4 questions to carry into every case study as we go into it. One is, you got to ask yourself, what is the AI actually doing here? Is it predicting? Is it classifying? Is it generating new content? Or is it helping to detect something, maybe like an anomaly detection? And having this, being able to identify what tasks the AI is doing, would it be able to help us identify if the system is likely to be reliable or if it's not? Um, the second is you need to ask yourself, where does human judgment stay in the loop? Should it be before or after? So, because like I mentioned earlier, like a well-designed AI system, particularly in the water sector, where the risk is also high because people ingest water, drink water, and then it might have a health impact. It's important to just ask, what does a human review before this action, look like on, and can this system be overridden by like a human decision or human authority? And it's important to ask yourself, where does human in the loop, come in here? The next question you need to ask yourself is, what data was used and whose data is it? Now, this is important because, like I mentioned, AI is only as good as the data we use to train it. And data is also not without context. So there's a likelihood that if there is no proper context around the data used, it might have an adverse effect on the predictions the models will give. In low and middle income countries, for instance, we know there's a lack of sufficient quality data to use to train the models. So oftentimes models are trained elsewhere and are deployed in that context. And there's a challenge with that. The challenge is that we might have something called a context bias, because the AI system was trained with a different kind of data. When they interact with other data, they're likely to produce very wrong decisions. So it's important to ask yourself there what data was used and whose data it is. Lastly, we want to ask yourself who benefits and who could be harmed by this. Because AI tools are optimized for efficiency oftentimes. They can inadvertently deprioritize underserved or hard to reach communities. So you need to ask yourself who's the intended beneficiary for this, and how equity was designed into the AI system, and what failure modes look like for those who are the most vulnerable users. Thank you. So if you've got questions, look forward to it much later.
Thank you very much, Dr. Shigan, for your presentation and framing as we head into the case studies. It's an important reminder of the limitations of AI and the historical point of view within our sector. Now we'll hear from our first case study from Peter with the Water Project. Peter, over to you.
Good morning, everybody. Just a pleasure to be here. Excited to hear the opening keynote this morning, and gets my brain going again. I am the founder of the Water Project, if you don't know me, and the Water Project is a water organization here in the United States. We've been around for about 20 years. I was the founder of the organization and CEO for the first 18 years, and also responsible really throughout that period for building our tech. A lot of our tech was a key enabling tool for what we did. It allowed us to scale a little bit faster than we might have. And so just be aware of that. I bring some of that tech background into this discussion. And so I'll be looking forward to questions where I've glazed over some things. Hopefully I won't do that too much. But what I hope I can share with you today is what AI is really, what we're so excited about, and what we're so excited to share about AI is that this kind of we want to call it competitive advantage we had of having a tech person in-house for 18 years is really now going to be unlocked sort of writ large across the water sector through generative AI. One of the categories that Samuel talked about are these chatbots that you maybe have had some experience with, and you may be hearing that they're very good at coding. If you're very good at coding, you're very good at tool building. And so we're going to talk about a tool today. We called it the shot calc because we only had 4 days to name it, because it only took us 4 days to build it. Here at the Water Project, that tool is deployed and in use. It's being used today while we're on this call. It's an operational problem of dealing with shot chlorination in the field. Talk about that in a second. And the role that AI played is that it built the tool for us. So on to the next slide. What is shot chlorination? Why is the Water Project even talking about it? Like I said, we've been around since 2006. We work in Kenya, Sierra Leone, and Uganda, and we work under a 100% coverage model. That means our goals, we've matured as an organization. If we learned what it really takes to solve the water crisis, is we have settled on 100% coverage. And that means that we are meeting the needs of everyone in a particular region. And what we learned along the way is to do that, which I think everyone on this call is learning as well, is that maintenance and monitoring and keeping up with these hardware solutions is absolutely critical to doing that. We're never going to hit these full coverage models if we don't take care of these projects. And so we started doing that a number of years ago. We built and maintained wells. We funded them early on. And as they started to break down, because they do, we got into the maintenance business. And when you start working on these wells, you get them dirty. You pull the components out of the wells, you lay them on the ground where there's feces from animals and runoff, and you contaminate your well. And so that would show up in the data when we would do water quality testing and find after a repair would happen that there was a mitigation that would need to be put in place. And so how do you get bacteria out of a well? You shock it. That means you put a lot of chlorine in it all at once to knock that bacteria level down. And then you have to make sure that that's cleared after a certain amount of time so that it's safe to drink again. For us, that's become routine. We do it after every well maintenance. It's remedial when we find E. coli in between or at a water quality visit. When we actually do water quality testing on our wells, we'll intervene with shock chlorination. And as I said, this is critical to get it right. The inputs, the well diameter, the depth of the water, where that static level is in the column, and then you have to do that. I think it's trigonometry. I'm not a real math guy, but you have to figure out the circle and the volume and the column to figure out how many gallons are in there, and then on to how much chlorine you put down that well. How did we do that? Next slide, please. We had paper charts, like everybody has paper charts. And so these are just mathematical calculations that put well depth and static level next to chlorine concentrations. Our techs would carry these around. They do carry them around in the fields in their field bags. And as you can see, this is actually, I believe that's Emma in the field with our team in, looks like Sierra Leone. And in the bright sunlight, in the dirty areas after you've pulled all that stuff out, things are getting wet, hands are dirty, hands are big, sun is shining over your shoulder. These things, they're okay. But if you want to talk about margin for error, you look at those tiny little numbers on a bright day with a tired tech, and it's very easy for errors to creep in a system like this. And so we thought, what if we could move from what's on the left in this picture to what's on the right? What if we could build an app? So next slide, please. And I'll talk about how the idea came about, because that's interesting too. And I think will start to play out in more water. I hope it starts to play out in more water nonprofits across the board. It's a fun story. But this is what we built. So this is sort of the preview. So you have it in the back of your head about as I start to talk about how we built this. We wanted a very simple way to enter a few set of numbers, no distractions, nothing else that the web app can do. It's not connected to the internet. It doesn't need to be connected, so it works when they're out in the field. We wanted to make the buttons big so they could touch them with gloved hands. And we wanted our partners to have some preset values, because we know, well, our well casings anyway come in pretty standard sizes. So not having to type numbers in every time was helpful. So we thought about this for a little bit. We sort of replayed what we had seen happen in the field with our techs, and we did the first iterative design of this app. And this is what it's on the screen. Tell me the well depth, tell me the static level. We had some preset concentrations, which we set at the leadership level. Like, we know what those numbers are supposed to be. The techs don't need to figure that out on the field. It doesn't change. So that's hard coded in the app. And then it literally gives them a number of scoops to put in the well. And per partner, we can determine what that scoop is, because a scoop may be a different size at a different partner. It just simplifies the whole process. It makes it step by step. It walks the tech through. There's nothing that can be missed, and the calculations are determinative at the end. Next slide. All right, so you'll see this slide a couple times today, and this is just a sense of what we built and where we are in this understanding of how AI might fit in your org. What stage of maturity is our app? As I mentioned, it's deployed and in use. So we're actually using this. You can actually build tools that actually do things in the field with AI. Generative AI. I know we've been doing it in machine learning for a while. The problem that we're supporting is operational. So these are day-to-day problems. These aren't big platform issues. We are not determining new forecasting models. We are not setting and charting a new path for community intervention, in behavioral models and things that, no, we needed a calculator. Very simple tool that did a very simple thing. And frankly, we couldn't afford it before. And we'll talk about that in a second. And where it sits in our workflow is this is a field tool, right? I just talked about that. All right, next slide. Let's jump in. Right, so the work in the field, and this is the fun story. Allison, who is our head of our head of monitoring, evaluation, and learning at the Water Project, I think she was just overhearing me in my office as I was encountering these generative AI coding tools, getting very excited about the things I was able to build. I was putting up new websites that we didn't have before, tools for marketing, some fundraising stuff, just little things here and there that was really exciting to see how AI and how it could build some determinative code tools, little tools for us, could really accelerate our work without bringing on additional headcount. We're not hiring new tech people. It's just like having a new tech colleague in my office. Actually, it's like having 10 of them. And so she came into my office and said, hey, we have this problem in the field. She described exactly what I did above, text in the field with paper charts that kind of cumbersome, don't work so well. Hey, Peter, and it was a very timid ask, because anytime you ask a tech person for an app, their eyes get all googly and the number signs come flying out of their ears, because when you say app, it feels very expensive, and in the past it has been. But she asked, she said, could we build an app to do this calculation? And boy, old me knew that's probably like $10,000 of quotes and lots of iteration and a whole bunch of meetings and spec and all this kind of stuff. AI enabled me, thought, this is a problem we could probably put in front of a generative AI like Claude, and it could probably turn around a usable app in a few hours. Not $10,000, but essentially free. So what if we could build that mobile first calculator? Maybe we could make sure that it's a PWA, so it's not an app, doesn't have to go in an app store. It just works online, and then as soon as the person is offline, it continues to work. We want to build and ship it fast. And then early, we even had an idea of maybe sharing it with the rest of the water sector. All right, next slide, please. Pardon me. Okay, what do we do? It's called vibe coding. Vibe coding is a term that was coined by Andrew Karpathy. He actually was a co-founder and inventor of OpenAI. And vibe coding is like, it's exactly that. Building a tool on a vibe, an idea, a problem, a constraint, something small, something definable, something you know, and that's the big key. You are absolutely the human in the loop here. You are defining what done will look like in this app. You're not asking ChatGPT to figure out chlorination, shock chlorination. You're not asking ChatGPT to come up with your process or to figure out what the numbers and the calculations and the algorithms should be. No, we are the domain expert. We know what those calculations are. We know what the answer ought to be when the numbers are plugged in. What we want AI to vibe is the look and the feel. How's it going to show up on the app? All the back-end stuff that's it's just cumbersome. Code is kind of hard to write sometimes. You have to manage dependencies and structure. You kind of have to know what code is. You have to have a sense of user interface. That's what UI is, of how people press buttons. All kinds of config files and stuff that have to be built in the background. What if somebody else could do all of that? AI did all of that for us. I had Allison and Catherine on her team literally write me 2 paragraphs about how they thought this app would work. We gave that app to the tool, and it spit out working code within literally within 10 minutes. If we could go to the next slide, please. This was our process. We ideated, so I was sitting with Allison and Catherine, kind of thinking through how they would use this in the field. We co-crafted a spec, which just meant that we wrote this all down in plain English. That's all it meant. And there was no fancy words here. We didn't prompt engineer. We didn't figure out the right way to ask AI. We just talked to it. Then we actually asked AI to give us a plan. And this is one of the cool things, if you've kind of worked with generative AI in coding, is the planning step. Watching it lay out how it's going to build your app is a great validation step in your process to understand what is it building, what inputs is it going to take, what's it going to do with those inputs. Show me in plain English the equations you're going to apply to that. This is another step where you as the domain expert are validating what it's doing. This isn't in code. This is in English. This is a plan that you would have like with a project manager around a table in your office. You're just having it on a computer. And then from that, we literally asked AI to build it. It predicted it was going to take 12 weeks if humans did it. It built it in 10 minutes. Really fun to see. So we were playing with it that afternoon. I literally could walk back to Allison's office. I think it was on a Thursday. She asked. On a Friday, I showed her the app. And we were iterating over that app on the Friday, knowing that potentially we could deploy it in the field for testing the next week. What I want to stop and say here is, what made this quick to market, actually, we can go to the next slide because it is how we didn't get ourselves into trouble. Very limited scope. We're talking about determinative tools here. It's a calculator. Just as if you were going to redesign a calculator that you use in elementary school today, 1 + 1 has to equal 2. 8 + 8 has to equal 16. Every single time, no matter how I type it in, upside down with the calculator turned over, 8 + 8, or, it has to work, and there's a way to validate it. So we had the rules. We knew once the tool built the tool, we would know if it worked or didn't. We also didn't have any databases, didn't have any APIs. We weren't connecting to anybody's data. We don't need authentication, no passwords, no users. That makes things simpler. This was going to be a small enough app that I, as a coder, could read it from end to end. And again, we knew that every formula was going to be verified by human calculation. So keep it small, validate your outputs, and then also keep this in mind. Your AI tool, as you're using it, is constantly getting better. So always be thinking about the next thing to build. I just have to sprinkle that in there as a builder, coder, dreamer. A really fun part about working in AI code is the iterative process. You're going to be adding features and polishing it as you're building it. Instead of waiting for like version 4, you're going to get something very usable and very intuitive if you really spend the time to think through the problem with the tool. All right, next slide. We're almost wrapping up here. Where we are versus where we're going. So we've built the app. As I said, it's in the field. We've got a step-by-step workflow. We can support boreholes and hand-dug wells. It's offline capable. We do all the input validation with the teams. Today, it's coded for just the water project and our partners. We actually have this launched across 3 disparate partners who all work on 3 different technologies. Some have hand-dug wells, different depths, different dimensions. So they all have their pre-configured solutions in their version of the app. And where we're going and what we're excited to announce is that we're going to make this app available for everybody. So please don't build a shot chlorination app with your AI. We have one that you can use and iterate on if you want. We're going to release it open source, which means you can use it immediately. We'll give you instructions on how to plug it in, or you can iterate on it. You can plug your AI and make it work for your team. We created a profile builder so that you can set it up with your organization's logos and disclaimers and defaults and partner names and all of that in there. And again, we could do this quickly, and we could do this at no cost without any approval from a board for extra budget, because it was AI with tokens we pay for on a monthly basis. And it was just like, could we add this value? Could we do it quickly? And about an hour later, we had this kind of next version ready to go. And that's really exciting. Next slide. All right, here's some quick recommendations before I let you go. If you're exploring this, start with a real problem. Don't start with a tech. Find out something that's broken in your org. Listen in the hallways for little things that maybe you've written off in the past because you've always known they were just these small problems that were too expensive to automate. But boy, it'd be great if you could. Boy, there's going to be a sweet spot in orgs for AI coding tools there. Again, small, bespoke, purpose-built. Write your spec first. Understand what you're trying to do. And make sure you can validate your outputs, because that way you'll know if your app works or not, because it's no fun if you don't know if it works. If you're actively building, keep your scope tight. One tool, one job. Deterministic outputs. I keep saying that over and over again. It's math, not judgment. And build it so someone else can maintain it. What I mean by that is ask the AI to explain what it's building at every step of the way, every line of code. It can write the line of code and it can explain what that line of code does. That sets you up to be able to read the code, even if you're not a coder, because it's in English. It also sets up the next person you bring in to be able to understand that code. Everything you build will need to be maintained. That's true for water. It's also true for code. If you're deploying, some of the tips we learned on this was offline is really not optional. Everything needs to be offline in the context we work. That actually is manageable with AI. That used to be a big cost to add on to an app, the offline capability, storing stuff locally on devices. The AI is just brilliant at doing that. And so we just built it into the app. Just works. And build configuration in from the beginning. It just makes it easy if you want to share these tools with other people. And I think I'll leave it there. There's probably a ton of questions. We can go to the next slide. At the Water Project, this is what we're learning. Though I am someone who, as a founder, loves to think big and wants AI to solve giant platform problems today. I was surprised, and then also really found the magic in thinking small. Build the tool you need, not the platform you're trying to imagine. Thanks, everybody. Peter at the Water Project, happy to answer any questions in email. Check out the app. There'll be a link to it in the resources, and we'll look forward to questions at the end.
Awesome. Thank you very much, Peter, for that excellent presentation and strong final message. All right. Next, we'll hear from Dana about Aquaya's work on Project W.
Thank you, Audrey. I'm Dana Hansberger. I'm a Senior Research and Program Manager at the Aquaya Institute, and I'm glad to see some familiar faces here today. And I'm so excited to share Aquaya's case study on integrating AI into our WASH data library, which is called Project W. Next slide, please. Thank you. So first, a very quick overview of the Aquaya Institute for those who aren't familiar. We're a nonprofit focused on WASH research, and we have 20 plus years of experience diving into tough research questions to drive better water and sanitation decisions. And we have a few hubs, but our research experience and staff spans more than 33 countries. And we actually built Project W internally out of our own need to find and use data across our research projects. The reason being that we were finding that the data is out there that we are looking for, but it is scattered, or it's inconsistent, or it's hard to find, it's hard to compare different data sets, and it's hard to trust which data sets are the most recent or the most reliable. And we also saw that without reliable data, decision makers struggle to create effective policies and strategies. We know that funders will struggle to identify and prioritize the most critical areas for investment. And we know that implementers will struggle to maintain efficiency and effectiveness of their on-the-ground efforts. So for example, needing to recreate a primary data set that might actually already exist uses time and money that could be spent elsewhere. And we were facing similar challenges internally. Next slide, please. We work with data all of the time, so we needed a tool for ourselves to help solve some of those challenges. And that's why we created Project W. And then we've decided to expand it and open it up to the public as we've understood its usefulness to the sector. And one note here as I go through this case study is that I'm speaking broadly about water sanitation and hygiene data because Project W is created with that framing of WASH in mind, but data that's relevant to water security and resilience is a big part of the available data sets that are cataloged on the platform. So Project W, what it is a powerful data library of publicly available secondary data that's been curated by our WASH data editors, who are actually humans and not AI. There are 4,700 data sets live as of now, and there are many more drafts that are in the review queue to increase that number. And these data sets come from more than 950 organizations. They represent over 280 geographies, and this all adds up to millions of data points. And critically, Project W isn't just aggregating data sets, we're also curating the data that gets added, and we're trying to emphasize usability of that data once it's linked in that library. Slide, please. So there are two main components to Project W. One is a free public data library that is soon to launch in the coming weeks, which is primarily what I'm speaking about today with our use of AI. And then second, we have a paid services arm that's been up and running for a few years now, where Aquaya experts provide advanced data analysis services for clients, and we leverage the Project W data library to do that. Slide, please. So to put our AI intervention in context, and you'll be seeing, as Peter mentioned, you'll be seeing this slide in all of our case study presentations. We've deployed some elements of AI on the platform, and we have others in development, so we're spanning those two areas. The AI is primarily supporting an analytical problem that we were facing, with a little bit of operational thrown in there as well. And then the AI sits in the data infrastructure and also the analytical systems workflows. And I'll expand on these areas a little bit more. Next slide. So as we developed Project W for the public, and we've scaled it from that initially internal tool, a few challenges became clear, and we identified AI as a good resource to address those challenges. And our goal here really in integrating AI is to see how far AI can support data analysis from data discovery all the way through actual analysis, keeping in mind the parameters that we want to put on the AI. So we identified 4 main elements that we wanted to investigate AI to solve. So one, we wanted to make the search and identification of data sets easier for users within Project W. As I said, it's this massive data library. We also wanted to find and add new data sets to the platform to keep current. 3, we wanted to make sure the existing data sets that we had linked stayed updated, and to reduce broken links and things like that to stay useful. And then 4, we wanted to have more chances for users to actually engage with the data through analysis and things like that. And we needed to do all of this with limited human and financial resources, which I know is a very familiar challenge to many of you here. So we've partnered with Baobab Tech to use their already developed Wash AI resource to integrate it in and power the Project W web platform. Slide. And as I've mentioned, we have deployed some AI features and others are still in development. One thing that was surprising throughout this process was how important it is for your platform, in our case, to have the supportive infrastructure to actually enable AI to essentially plug in. That's something we did not have originally, so we've spent some time updating the website on the back end to enable this integration in the first place. And then the other thing we've deployed is a natural language search in the platform powered by AI, and that's what you see in this little demo video here. So users can actually search in plain language and find what they're looking for. So previously, users would need to know exactly what they were looking for before searching, or they need to use a bunch of filters to narrow that search. But now AI will surface relevant data sets to my query, and I can support that with advanced filtering if needed. But if I'm looking for, water quality data in Kenya, I can just type in the terms that pop into my brain, and AI will bring what I'm looking for to the front. And the feedback we've gotten from testers since we deployed this has shown what we were hoping, that the updated search has decreased friction and helped users to find data faster and more efficiently. And then AI features in development on the right side of the slide are around discovery, curation, user suggestions, and analysis to make Project W a reference librarian and a basic data analyst all in one. So that's around finding new publicly available data sets and drafting the metadata for those, cleaning the data to flag outdated information. And then we're also investigating ways to guide users via an AI helper to answer research questions by suggesting data sets that could be relevant or conducting basic data analysis also in support of those research questions. Next slide. So all of these elements raise important questions about guardrails. AI can do many things, and we find new things every day, but AI cannot do all things. So we implemented that human in the loop concept, which you heard Samuel mention. With this, humans are directly approving AI action. So if AI identifies a new data set and populates the metadata, a human reviews and approves it before that data set goes live on the platform. Humans review and step in if there's any issues or any ethical concerns. So we'll monitor to see if AI is weighting new data set discovery from a particular geography, for example, and we'd correct for that. And so from that list I shared on the previous slide, you can see this division here of tasks that AI can lead on and where humans review in that loop. So humans are still approving all data sets before they're live. Humans are directing AI on key topics to search for new data sets. And then in addition to that quality assurance, humans are also taking action on any issues that AI might flag, like an outdated data set, or issues that users might flag. And humans also would perform the advanced analysis that I mentioned earlier with that data services tier. Next slide. So before I close, just a few key takeaways from this case study, and some of these you'll see in common with other case studies as well. So first, it's important to start with a clear problem and determine whether AI is all or even part of the solution, rather than just doing AI for the sake of AI, as tempting as it may be. And additionally, we found that AI was best used for targeted insertion to solve problems rather than broader decision making. And as I mentioned, we learned the importance of making sure that AI is talking to the right functions of your infrastructure for smooth usage. And then once you have AI used for part of your work, it's easy to expand, but there's still trade-offs with scaling AI around the human oversight, the time, and the potential for overrun. And then related, don't try to automate everything, especially all at once. This is part of why we're rolling these features out in stages on Project W to make sure each one has been tested and reviewed and serves a true purpose. And then that human in loop approach to give us confidence that we're still delivering on the human oversight for the quality of the data sets and the utility of the platform. Next slide, please. So to close, we are planning to launch Project W beta in the coming weeks, which is incredibly exciting. And you can sign up to get early access by using the QR code or by going to projectwdata.net. And this will be shared out following the webinar as well. And that data services arm is available now, and you can find more information at the URL as well. So I look forward to seeing you all in the Project W platform and answering some questions later. Thank you.
Thank you very much, Jana, for that excellent presentation. And we encourage everyone to sign up for early access using the QR code on screen. Finally, we'll hear from Liz at World Resources Institute on the work they're doing around AI.
Great. Thanks, Audrey. So hi, everyone. My name's Liz Kosha at the World Resources Institute, and I'm also joined by my colleague, Tinabeb, who will sit on the panel. Next slide, please. So for those of you that are less familiar with WRI, we're a global research and development organization that works at the nexus of the environment, economic opportunity, and human well-being. Next slide, please. Yeah, so our water program focuses on water modeling, water governance, and nature-based water resources management, which includes the protection of the quantity and quality of the sources of water that wash systems rely on. So we leverage the data from our Aqueduct suite of tools. And Aqueduct is a screening tool that's used to evaluate water risk, inform policies, and assess different water management strategies. So our tools have reached hundreds of thousands of users around the globe and informed decision makers both in and external to the water sector become better water stewards. It's also globally consistent, open, and peer-reviewed data. Next slide. Audrey, there you go. Perfect. So Aqueduct's been really successful, but there are still some challenges that we hope to improve on. So it's not always being leveraged to its maximum effect. There's so many possibilities with the data that we have to do scenario analyses, or even we just get so many questions from users that we just don't have the capacity to answer. In addition, it's a global data set, so that doesn't always answer questions for local on-the-ground work. And in addition, those that aren't as comfortable with data analysis, get a spreadsheet like the one you see in front of you and don't always know how to use it or read the data. So what we're trying to do is improve on that. Next slide, please. And that's where Aqueduct 5.0 can come in. So we're shifting from the static data platform to an AI-enabled decision support system for water risk. Our static maps have been really useful, but they're limited in how users can engage. So Aqueduct 5.0 will be this interactive, question-driven exploration where our AI will guide users to the insights most relevant for their decisions. We're going to use ensemble modeling instead of just one model to bring together multiple different models and find and increase our accuracy in that way. But really importantly, too, we are going to have explainability. So users understand why results look the way they do as we add more models and more complications in some ways, right? So Aqueduct has also always had this really strong global coverage, but we're going to use AI to incorporate local data, research, and projects to contextualize these different data sources into actionable insights. In addition, we're going to incorporate real-time alerts with AI helping to detect patterns and emerging risks so that users can respond faster. And then finally, we have many different tools and places to get this information. But instead of navigating all of those, we're going to have everything sit on this unified data and AI foundation. So it's easier to access the exact data that you need for your decisions. Next. So as Aqueduct evolves, what we're doing at WRI is really learning from our other products that we've already created. So one of those is Global Nature Watch. And Global Nature Watch is an experimental open AI-powered system that combines peer-reviewed research and a simple chat-style interface to explore ecosystems worldwide. Users can ask questions in plain language and receive AI-assisted responses supported by maps, stats, and context. It allows real-time monitoring of the Earth's surface, regardless of your technical expertise. And what we're trying to do is incorporate aqueduct information and more water information onto Global Nature Watch. So how does it work? Next slide. Great. So you ask a question, and there's a system of agents that identify what data set in our data catalog can answer your question. And then it only goes to our vetted data catalog of peer-reviewed WRI or partner data products. Next slide. Great. And then it collects the information about all of the data to share information with you on what data set it's using, what are the methods behind that data set, how can you interpret the data, and it summarizes its findings into charts and text. Next slide. Okay, so let's look into a demo of an aspect of source water protection. So we're asking Global Nature Watch how land cover has changed in Lera, Uganda over the past 10 years. The agents are working together to understand the request, identify the data, and here we can see that there's a chart that shows that built-up area has increased and wetlands have decreased. It also then, you kind of scroll down and can see the relevant metadata or the data about this data. So we're scrolling down. Okay, and now we can then ask how these changes in land cover impact local hydrology. So we'll think and then tell us that built-up areas mean that there's more water runoff and less seeps into the ground, replenishing groundwater supplies that we might get our water from. In addition, losing wetlands means less reliable water storage, especially in the drier months. Okay, next slide. Great. So with this new integration and then additional data advances that we're working on now, this geospatial AI that incorporates Global Nature Watch and then Aqueduct 5.0 can help us answer a number of questions, like diagnostic questions, like where is land cover change depleting groundwater in wells that this community gets their drinking water from? Scenario questions like how will climate change affect my community's water source? Planning questions, where can conservation projects ensure water quality improvements and impact monitoring? So like what intervention was most effective in improving the source water quality? Next slide. Okay, so Global Nature Watch and Aqueduct are established tools, been around for, well, Aqueduct like 10 years, Global Nature Watch just one. But this next phase and integration of Aqueduct 5.0 and AI integration are still very much in the planning phase. They'll support data analysis and insights, but since we are still planning, we're still thinking of ideas and getting feedback. If you'd like to join us on this journey or have thoughts or opinions, please reach out and let me know. Next slide, please. Okay, so what have we learned at WRI testing out AI? So AI can enable so much automation of labor-intensive tasks. We've been using it for image classification for many years, and it can accelerate our understanding of environmental changes and dangers to water supplies. But there are some challenges, right? We've heard that AI can hallucinate from our other speakers or provide incorrect information, or there's biases associated with the source data. So uneven inputs from different areas around the world can introduce different biases. We're also seeing, right, in the news often that it's using significant water and energy resources that can actually hinder the environmental systems that we're trying to use AI to protect. But it can empower broader participation, so allowing non-experts to report on water pollution or water leaks. And it can also improve the speed and the scale at which information on nature or ecosystem conservation is produced and used. So AI is a tool that we can leverage to reduce technical barriers and lead to broader and more inclusive participation. Next slide. So I talked a bit about these challenges, right, on the last slide. So moving forward with AI, WRI has some guidance in our approach to using AI responsibly, right? So in terms of what we're trying to do, we want to make sure that we're evaluating and learning from each stage of our project development, right? So we also want to measure the environmental and financial costs of AI and share that information with the user, saying this is using this much water, make sure it's a good request, right? We're also facing this new AI opportunity together. So we want to be clear when we're experimenting or releasing a tested product. And then we also need clear rules of the road. So ensuring that a human's always in the loop, or when we're using AI, we're not sharing sensitive information with that an AI that will then train other models. And finally, we're building this community around the responsible use of AI. We're talking to colleagues, we're doing these webinars to learn from each other, and we're going to continue to do that. So thank you so much, Audrey, and back to you.
Awesome. Thank you so much for that wonderful presentation, and just overall, thank you to all the case study presenters. It's so exciting to hear about all of your work. Next, I will hand the floor over to Olivier Mills to moderate our panel and audience Q&A session. Olivier is the CEO and founder of Baobab Tech. He started building software at 15 years and never really stopped. And over nearly 2 decades, he's worked across Africa, Asia, and the Caribbean on WASH, humanitarian, and development initiatives. Olivier, I will hand it over to you to get us started.
Thank you. This is very exciting to see so many great applications of AI in the WASH sector. At Baobab, we work across multiple sectors, but I always have the water sector at heart, having that from my background. And so yeah, we've got a few more people. We had the 3 presentations. We have a couple more people that I'd like to bring on for a Q&A. So I'm going to bring them on one at a time. Please make sure if you have any questions to use the Q&A button. If you can't see it, you might have to open your window a bit more, but there is a Q&A, not the chat. It just helps us organize the questions. And if Peter, there's a couple of questions on yours, just feel free to answer them in the comment as well, just so that we have more that we can bring out loud. So jump in on that would be great. So for our first panelist, a few additional panelists that I'd like to bring on is Kelvin Gachuru, who is the founder and CEO of Moby Water, a smart water monitoring platform that helps NGOs, schools, and utilities track and optimize water systems in real time. So that's Kelvin from Moby Water. So the question I had for you is, you're working with real-time water monitoring, which I think is like a big topic within the water provision industry. And you haven't fully brought in, my understanding is you haven't fully brought in AI into your organization, into your work. What are the typical questions, when you focus on something that's so important as water monitoring, what are the questions you ask yourself to decide if and when AI makes sense, for your organization? I think AI has sometimes been this big sort of like, we call it AI washing, like with greenwashing, where you just like sprinkle AI on everything. So what types of questions do you ask yourself? You're deep in the operations of water supply. What would be maybe holding you back in that space?
Okay, thank you, Olivia. I think as Mobi Water, especially since we work in the sub-Saharan Africa, currently monitoring about 42 million liters of water daily. And this from large water utilities to your small community water kiosk or schools usage. One of the things that we ask ourselves, especially when using or trying to think about AI, is do we really need it, especially in our context? I think one of the things that has been mentioned over and over again is AI is only as good as the data that actually trains it. And if you look at smart water deployment, especially systems in Africa, it's still at the beginning. Now is when we're seeing maybe mid-scale deployments across different countries, but it's still yet to really grow into scale where we have enough data to start training the models. So what we currently do is we use a lot of rule-based logic to do most of our predictive analysis, filtering analysis, and just that point of do we really need to incorporate AI at this point in time to maybe increase pattern recognition, to increase better accuracy, but better insights? So we still feel that we are still not yet there. We're waiting for at least more deployments to come in, more data sets to come in, especially relevant data sets, so that we're not just picking algorithms that are open source built for a different region and then incorporating that into our platform. In terms of some of the what holds us back, so definitely if you're working in our market, which is the sub-Saharan African market, you're looking at middle to low income communities. And as we all know, AI has quite a huge cost accompanied to it. And even as our platform is with our rule-based logic, if we do incorporate AI, then we would have to look at how do we make it more sustainable? Will the actual beneficiaries and users be able to either afford or pay, or would we have to offset that? So it's typically a sustainability issue is what we're currently trying to resolve around that.
Thank you so much, Kelvin. I do understand the margins are so small. So if you're augmenting with AI, how do you use those to build in your systems? Thank you very much. So feel free if you have any questions for Kelvin, drop them in the Q&A. Always use the upvote if you'd like to, because there's quite a few. So if you use the upvote, it brings them to the top for the participants today. So our second panelist we have with us is Nicholas Dickinson from WashNote. And so Nick Dickinson is an associate with RC Wash and has been supporting country-led monitoring and evaluation of water and sanitation services at both national and district municipal levels, where government, civil society, and private sector set the monitoring agenda and the questions to be answered. So from your experience, Nick, what, on water systems more broadly, seeing across multiple countries, so it's very close to the other one, but where do you see AI realistically helping versus, just, oh, AI would be great for this, and then it'd be just an idea? Where do you think practically are really helping to improve these systems? And where do you think maybe it's overkill or won't make much of a difference? So I know it's a broad question, so feel free to pick.
No, that's great. I mean, yeah, the marketed versus actual impact of AI is always changing. So, yesterday what was marketed didn't work, and today maybe it does. So it's a moving target, but I think we need to talk about two things. We need to talk about adapting to AI at a systems level. So it's not all about using AI, but sometimes it's about changing our strategies so we adapt to AI in the availability of these tools, especially if you're publishing data about anything, about services, about governance, about finance in the sector, then you need to be at least start to think about how your data is going to be used by AI chatbots and start to think about what that should look like. So when it's used well, what does it look like, And if I try and go to Claude or another chatbot, how does it use my data actually? Is it interpreting it correctly? Is my documentation good enough? And am I giving enough guidance around how my data should be used? So am I actually speaking to the system, right? That's the kind of basic information that we think, oh, of course people understand this data. So we put it out there and it'll make a change. One, people don't. And so you need to explain it. And two, it's becoming way more accessible now because there are all these chatbots. So I think that's one aspect I wanted to touch on, is just that adapt part. I think it's important for brand, and I think it's important for trust. And if we look at systems change, if we look at leadership and decision making, the really important assets are kind of trust, and quality information. That's what's going to make the difference, right? And that's when people will start to listen. Otherwise, they might listen to other voices that don't have a lot of evidence, but they have the trust, right? So I think that's one thing we need to think about at systems level, and that means all those levels you mentioned earlier. So the other thing is, it's exciting what you can do today in terms of like linking more qualitative data sources with our quantitative ones. How many people are getting a service, but how does that compare, for example, to the presidential compact that was published, or the legislation, and the expected level of service in that legislation? Nowadays we can actually have our chatbot read that legislation and actually say, oh, these are the regulations in it. And before, I think my eyes would have probably glazed over if I had to read legislations from 20 countries, but now in principle, that sort of thing is possible, which is exciting because it means that we can also make these things that are really dense, but important parts of the system, available to people in more visual ways, where we can say, hey, this legislation says you're supposed to receive this amount, and now this is the amount that's being received, right? So I think, at a high level, that's kind of what I would say. I can always go in more detail if there's time.
Yeah, thanks for that. It is interesting. I feel in this era of AI, the idea that so many reports or so many like legislations don't get read, and we now have this opportunity to access all of that. So both what we call the unstructured data, like reports, but then also in being able to process data sets, like you mentioned. So yeah, thanks for your insight there. Again, if you have questions, drop them in.
I just wanted to add.
Okay,
I mean, and some of the data sources that we aren't using as much, I think, as we could, are things like sector reports, right? Those already exist. The data is often in a report, but if you want to pull out data from multiple years, that's validated data. People have looked at it and talked about it. Yeah. So anyway, that's.
Thank you. So our third additional panelist we have with us today is Tinaba Bihanes, who's a regional geospatial technical lead at the World Resource Institute, working at the intersection of water resources management, geospatial analysis, and data-driven decision-making. So, Tinaba, the question I had for you is so both the Global Nature Watch, which was presented there, and the Plant Aqueduct aim to make complex data more accessible and easier to use, as was presented by Liz. How do you ensure that the AI-generated insights actually translate into better decisions? Because the tool can be great, and how do you see that conversion or that translation happening from your perspective?
Yeah, thanks so much, Oliver, for this question. Yeah, as WRI based in Ethiopia, in Addis Ababa regional office in the WRI Africa, we are actually very close to the local context. So I would answer this in 4 layers. The first layer that I would like to share is that many of the presenters have been talking about the contextualization and the trust. So the first layer that I would like to highlight is the contextualization matters. What does it really AI translate into, especially for non-technical users? As I'm interested, for example, non-normalized difference vegetation index for non-technical user, what does this tells? So the AI really helps to translate this kind of terminologies, technical users, to be able to be contextualized in a local context. And as WRI working in a local context, this would be helping to translate the non-technical abilities of the AI would be like using as a translator. The second one that I would like to suggest is the co-creation, the co-design part of it. So the co-creation is, for example, when WRI introduced Aqueduct for the case of Ethiopia, it's actually been used as a data that is from the Ethiopian context. So this was not from dumping the the data and everything of the aqueduct into the decision makers. So what we did where we co-designed with them. My colleague were sitting in the National Ministry of Water in their office to really co-design the aqueduct in a local context way. So the co-design and the co-creation will take the second stage of the layers. The third one is moving data into decision. We have contextualized it and co-designed it, but what happens next is to be able to translate that data into decision. What does it tell? For example, if aqueduct is telling us the water stress, what does it mean to the context of the decisions? So be able to use that for a decision. And then finally is building trust, transparency, and be able to do that in an iteration way. Are we going to use that and be able to do tomorrow to have that data, AI be able to products and be able to translate that in a trustworthy way? That would be in iteration. In WRI, what we are actually working on is having a lot of dialogue with the decision maker, with a lot of ministries in Africa, not only in Ethiopia, being able to also be able to, in the worldwide, having the transparency, trustworthy way of contextualizing the AI products, especially when it comes to the ecosystem and the water sector. Oliver, back to you. Thank you so much.
Thank you. Yeah, I'm hearing over and over again, the more we transfer the interpretation of data to AI, the more the trust has to increase, and kind of they come together. The more we're asking AI to interpret data, to bring data together, the more we have to ensure that we can build the same level of trust. And I think what I'm hearing a lot is also with how you generate trust is accuracy, right? So if your system is just spitting out different outcomes every time, how can you trust it? And so that is a challenge I'm hearing a lot from organizations, is how do you balance providing something that can be like, a data analyst in your pocket, like Dana was talking about, is like, how do you do simple analysis for the user, but then how do you make sure humans can be involved in either contextualizing or providing more advanced analysis? Thank you, Timur. So we've got about 11 minutes now left for questions across the panel. I've been looking at a couple of them in the Q&A, so please keep dropping them. If we don't get to answer your questions, we will be grouping them together and following up this webinar with an email with answers to your questions. So don't hesitate to drop more questions in there. We'll make sure that we answer them all and send the answers to you via email. So I'm going to jump in with one of the first questions here, which actually covers probably both for WRI and Dana a little bit, which I've heard across other sectors as well, which is how can any of your systems, or will they, or how do you address the issue that we're hearing around increasing the support to ground data collection? We know that, with a lot of defunding in some parts of the water sector, that we've been limiting the amount of data we're able to collect. How do you see addressing this challenge? Do you think this is still a challenge in supporting this ground data collection that basically informs the platform? Your platforms, both the Project W and Aqueduct depend on data collection. So I don't know if WRI wants to start, and then maybe Dana, if you have a comment on that as well, would love to hear from you.
I can be able to answer a few and then
Sure.
hand it to Jen. Okay, thanks so much, Olivia. Yeah, for us, we have actually the data collection from the field used to be a big challenge. Through time, it gets improved because of the digitalization, because the even changing image into some meaningful data, even drone collection, it's really getting enhanced in terms of the data collection, be able to ingest the AI world. And we are really working on that. And even for the water sector, currently, we have a project in the northern part of Ethiopia called the Tanase Basin. What we are trying now, what we're actually been able to work is a data collector from the Netherlands called WaterNet. And they are really having an automated system in place in the river to measure sedimentation, to measure water level data, and then be able to ingest that into the digitally collecting it into the ministries, regional ministers of water, for example, the Abai Basin Development Authorities, getting their data in real time and be able to feed that into a better analysis. So that's what we are actually working on, even to validate our remotely sensed data from the data on the ground. Over to you, Diane.
Yeah, thanks, Tanava. I think for Project W, a key component of Project W as a concept is helping folks find the data they're looking for, which also means helping to consolidate the number of discrete data collection tasks that are needed, perhaps. So if one organization has completed and published their data, like completed a data collection exercise and published their data on a specific area or a specific topic, then another organization could find and use that data rather than having to replicate and essentially redouble or duplicate efforts and the resources needed. Perhaps you can use at least part of someone else's data that's already been published. And I think the AI component can only enhance that as well. So helping people to find even more types of data sets that they may not have previously known existed, and also helping to maybe compare and contrast what's already out there and what you might need to supplement. So going back to that, challenge of limited time and resources and effort available now, especially as we see funding shrinking, I think this can only support that by enhancing the connectivity of the data that's already being collected.
Thanks. Yeah, I do hear a lot that there's still a lot of data that just simply isn't even being used because people aren't aware of it. So thanks for that. So while I have you, I guess, Dana, there's a couple of questions maybe you can answer briefly. One was related to what were the specific infrastructure upgrades that you needed to do on Project W, and then also if Project W plans to, or if it's intended to do any data cleaning of the actual data sets that you catalog to make them more comparable and consistent.
Yeah, sure. I put some quick responses in the Q&A as well. So for the
great. I didn't see that.
For the askers.
Yeah.
So I'm not, in the interest of time, I don't want to take up too much on this, but just briefly, like the infrastructure upgrades were really about making sure that the database on the back end was ready for AI to read it, to support that natural language search process. And then that will undergird us as we continue to deploy the additional AI integrations. And then on the data cleaning, so Project W doesn't directly edit the data sets ourselves. We link back out to the original hosts of those data sets, so we're not directly editing them. But as we get into that AI enhancement of doing some basic data analysis, then we will need some ways to compare and contrast. So I think there will be some components of that for those discrete analysis tasks, but not changing the original data sets.
So we had one big question from Nicola that I see Nick has already answered. I don't know, Peter, the other techie in the room, what's your take on, ChatGPT, Claude Gemini, Knowledge ML, Copilot, Mistral? There are so many Gen AI models with different and evolving capabilities and specialities and different costs as well. And with premium models, organizations are wary of the costs. You said you're using your own tokens to build your app. And there's a concern around privacy, obviously. And so the question is, what is a good process to use the right tool for the right problems? If there is one, what's your take on this kind of both centralization, because at the same time, we talk about the big tech, the big three that have kind of like control of centralized generative AI space. But yeah, and thanks, Nick, for your extensive answer. I wanted a separate take on that.
I think I can answer. I could start. I see Peter is also very eager to answer that as well.
Okay.
So I think, so you need to think about this not as a technology problem, but more of a problem you're actually trying to solve. Is there really a problem? Does it require AI to solve it? Because oftentimes the best AI is no AI at all, right? So you get to really figure out if there's a problem to solve, not because you're eager to use the technology. That's the first one. And the second thing to consider is that there are a lot of open source models, very, very capable open source models that you could localize, and you can build on-prem, infrastructure to support. And so one of the things you could do, like if I was to do it and I had to think through a roadmap, first thing I would think about is, first, is there a problem to solve? Secondly, if there is a problem to solve, how do we use AI to solve that problem? When you figure that out, you can go there are benchmarks for, I could share a link, there are benchmarks for practically all the models you can think about, including the open source models. You can look at which of them fits best to what you're trying to solve. Some models are better with things like mathematics, some models are better with coding, some models are better with like maybe generating text and all that. So once you figure out exactly what domain you want to solve, you could figure out which open source model to use. As again, it doesn't have to be very sophisticated as many people think, but these models are there just waiting for you, particularly, and this is not me making a sales pitch, but particularly many of the models produced by companies in China, open source like QWine models, and even the Alibaba models like are really, really good, very efficient, and you can consider using those. Peter?
Yeah, I'll push the question, maybe from a founder CEO seat, and how I would want to see it roll out in an organization. Not directed from mine, don't make those calls anymore, but find someone in your org or a group of people. There are going to be a couple people that have some natural affinity to this. Maybe they're already talking about it, mentioning it in the hallways. Get them the resource. Pay for them to be on the premium models. I'm talking to the folks that write the budgets here. Give those folks $200 a month, $400 a month to be on 2 of the models. Get the top tier that they can, and then let them play. Give them some time in their role to experiment, to put in some of their normal tasks. The beauty of being on the premier models is you are at a tier where you're not sharing your data. So your data is not going to train the models. If you're paying at these levels, you can check the box. So that will allay those fears. And the reason I'm encouraging to play with some of the premium models is to really understand the capability, that it is moving so quickly. It is not moving linearly. It is moving exponentially. If you checked in 6 months ago, it is completely different. It is a completely different world than it was 6 months ago. That's not an exaggeration. And you're really going to want someone that can kind of keep up with that. And then they'll play with the other models where you try to figure out, okay, how are we going to make this cost work across the org over time? You're not going to need all the capabilities of that premier state-of-the-art model, but you're going to learn what kind of the key, as Samuel said, some are good, some are better at other things. You'll start to figure out which ones are sort of the masters of which domains, and then figure out, okay, long term, how are we going to make this cost work? You don't want to sit at that premier level, but give some folks that latitude to play. And please do play at that premium level. It's a whole different ball game, and it's the place where those folks' imaginations are really going to open up, and you'll see some of those ideas come to the fore.
Thank you so much. I wish we had more time. We could spend another hour just chatting about all these options. So I'm going to have to hand it back to Audrey now. Thank you so much for this panel. Some really great minds here, and I'm very excited to see where we can take AI in the space of water security. So back to you, Audrey.
Awesome. Thank you all so much. I just want to wrap us up really quickly. I'll share some contact information and some key resources. So let me get those up. All right, once everyone can see my screen. All right, I just want to thank everyone again, all the panelists, case study presenters, everyone. It was an engaging event. I took away a lot of things. I hope the audience did as well. If you want to continue the conversation and ask more questions, please feel free to reach out to anyone who's spoken today. All of their contact information is on this screen. This will also be included in the resource guide, so feel free to take a picture, or you can wait and read that guide later. I also wanted to include a QR code to that resource guide. This includes full case study descriptions, additional reading, and contact information, as I mentioned before, for everyone who's spoken today. So read more, learn, engage, and let's continue this conversation. I will share the session recording and slides via email along with that summary Q&A. So if we didn't have a chance to get to your question, we will do so in that Q&A summary. And also stay tuned for our post-event learning brief. We'll post on the MW website and also on our LinkedIn page. So please follow us there, and we post events and other things that are going on, so don't miss out. And again, I just want to say one last thank you to everyone involved for making this possible. It was absolutely wonderful collaborating with you. And I want to say a special thank you to Allison Gregory with the Water Project for her work in shaping this event and her thinking around it. And lastly, to the audience for bringing your curiosity, questions, enthusiasm around today's event. Yeah, thank you all so much.
Thank you.
And with that, I'll close it out.
Thank you.
Thank
Have a
you.
great day.
Bye-bye.